أولى ثانوي. فرصة جديدة وحلم جديد وهنعديها بالتأكيد، وهنعديها بالتأكيد. أولى ثانوي.
أهلا بكم طلبة وطلبات الصف الأول الثانوي على قناة مدرستنا 3 تحت إشراف وزارة التربية والتعليم. النهاردة إن شاء الله هنكمل نيوتن's law of motion, and we will study today Newton's third law, and let's see what we'll take today. Let's go. We will start studying Newton's third law of motion. As we have taken the last session, we have taken Newton's first law, and we will continue for today. Newton's third law, let's see the objective for today. Explain Newton's third law and the mathematical formula, and study some examples or a live situation just to explain how it's work. To understand Newton's third law, first we need to observe some live situations or live force and motion. When you jump from a boat to the shore, okay? طبعا لو راكب في مركب صغنن كده وانت خلاص عايز تنزل من المركب دي او من على البوت دي تنزل على الشور او على الدك الموجود عندك ده، فانت بتعمل ايه؟ We have two forces here. You apply with your feet a force on the boat. هتلاقي نفسك بتزق البوت كده عشان تطلع على الشور على طول اللي موجود عندك ده. At the same time, the shore applies a force. The shore applies a force on your feet too, which means there is a mutual forces between you or your feet and the boat. In another situation, during your motion on the ground or on the floor, you exert a force. You exert a force by your feet on the ground. At the same time, the ground or the floor apply a force on your feet, which means we have two forces, which is called action and reaction. The action is you're applying force by your feet on the ground, and the reaction is the applied force with the ground on your feet. During the swimming, and if you swim, you push the water. If you are in this, you sink in the water, and you push the water downward, and consequently you find your body moves upward, which means you apply a force on the water, and the water applies a force in your body. If you play with the gun, when you shoot a gun or shoot a bullet from the gun apply a force on the bullet to make it to shoot it or to make it out from the gun. At the same time, the bullet during its exit from the gun, it's applying a force on the gun itself. لو انت حتى انا مش عارفه يعني ممكن تكونوا حد يستخدم الجن قبل كده، حتى اللي هو بتاع الالعاب ده، لما مش في اي حد بيشد ذا جان بالبالت منه، بتلاقي ايدك المفروض ان انت بتابلاي فورس على البالت الموجوده عشان تطلع، فتلاقي ايدك بتتحرك باكورد. او لو في البندقيه كمان بتاعت الصيد دايما بتلاقيها كتفك بيتحرك لان بتبقى ساند على الكتف. طب بتتحرك ليه اصلا؟ المفروض بيكون الاوبجكت نفسه او الجان نفسه apply a force on the bullet, and the bullet apply the force but in the opposite direction on the gun itself too. As you know, the trampoline طبعا كلنا بنلعب عليها، كلكم لعبتوا عليها اكيد. Just to make you upward المفروض ان انت بتعمل ايه؟ بتدوس عليها. You apply a force downward, and the trampoline apply an opposite force on your body that makes you moves upward. From all these examples that we have seen, or in our daily observation, we can define Newton's third law. All these are applications for examples for Newton's third law. A Newton's third law, which means or denoted as, when an object acts on another one by a force, the second object apply with a force on the first object, and this force is equal in magnitude but in the opposite direction, which means لو أنا عندي two objects والtwo objects دول واحد بيأثر على الأوبجكت بفورس، فالأوبجكت ال second object will apply with the same force on the first one with the same force, same magnitude but in the opposite direction. So a mathematical formula that expresses Newton's third law, we can note it just like F1 equal minus F2. Minus, which means it's indicate the direction of the two forces الموجودين عندنا, which means if you have a force F1 applying forward, the reaction or the second force will apply with the same magnitude but in a backward in the other direction or in the opposite direction. Newton's third law, we can, as you see for the photo that you see, action reaction force. When you push your colleague or your teammate in the work, he would push you with the same force. So you'll find yourself, both of you go far from each other. But we have some notes here, according to Newton's third law. There is no a single force can exist in the whole universe. أما فيش حاجة اسمها إن أنا عندي قوة واحدة بس هي اللي بتأثر على object موجود عندي. ليه بقى؟ لأن إحنا لسه قايلين each action has opposite and equal reaction. فبالتالي لو أنا في موجود عندي أي action force applying force هتلاقي لها reaction أو الرد الفعل بتاعها, فهتلاقي another force applying in the opposite direction, which means the force it's always pairs of force. طيب ما احنا هنرجع, حد هيرجع يسألني طب ما احنا كنا خدنا قدام شوية ان انا في عندي حاجة اسمها resultant force. الريزلتنت فورس دي بتبقى السمشن او التوتال force that have the total effect resultant by the whole forces اللي موجودة عندنا. تمام؟ دي حاجة ودي حاجة مختلفة شوية. ف first thing, there is no single force in the universe because the action and reaction are paired force. Paired force يعني مع بعض متلازمتين أزواج. الفورس دايما بتكون paired forces. They originate and vanish together. هما الاتنين بيحصل لهم producing وبيحصل لهم vanishing مع بعض. بيتولدوا مع بعض وبيختفي الإفكت بتاعهم مع بعض. Number two, or the second note, action and reaction are of the same type. لازم التو فورسز الموجودين عندي اكشن رياكشن يكونوا من نفس النوع. يعني ايه من نفس النوع؟ ما ينفعش يكون عندي الاكشن فورس عباره عن بوش فورس ويكون الرياكشن جرافيتيشنال فورس. لو واحده بوش فورس يبقى لازم الاكشن بوش فورس, الرياكشن كمان هيكون بوش فورس. gravitational force هيكون gravitational force. Just like the gravitational force applied from the earth on our bodies. احنا الارض بتاثر علينا بقوه جاذبيه. احنا كمان برضو الرياكشن بتاعنا اللي هو عباره عن ايه برضو؟ احنا كمان بنجذب الارض اللي موجوده عندنا دي بجرافيتيشنال فورس برضو equal in magnitude but in the opposite direction. بس طبعا الافكت بتاعها مش بيبان. دي هناخدها ان شاء الله في الترم الثاني لما ناخد الفورس وهنعرف هي عامله ازاي. زي برضو نفس الكلام, انا عندي المون والارث. الارث attract or apply with the gravitational force on the moon, and the moon too apply a gravitational force on the earth with the same magnitude. بنفس قوة الجذب ونفس قوة الجاذبية الأرض بتجذب بيها القمر هو كمان بيجذب الأرض بنفس المقدار. بس طب ازاي يعني؟ ده القمر صغير والأرض كبيرة فبدي هي اللي تجذبه. لا, دي هناخدها إن شاء الله قدام شوية لما ناخد نيوتن سكند إن شاء الله. طيب, one of the most important or frequent technical application for Newton's third law when you launch a rocket. عملية إطلاق الصاروخ نفسه. تمام؟ Okay, let's see how it's work. Just here to launch the rocket, it's based on Newton's third law of motion. Because you see there is a huge amount of gases or huge amount of burning gases that pushes downward. أنا عندي اللي هو بعد لما بنعمل burning للفولز بتاعت الروكت نفسه just to make it move, فبالتالي هي بتعمل big amount of gases, it affects or pushes downward. as a reaction, there is another force that applied on the rocket but in the opposite direction. بيبقى في قوة تانية بعكس الاتجاه. الغازات بقى نفسها برضو دي الجازز دي بتأثر على الروكت with the same force but in the opposite direction, which means it's upward. And this is what makes the rocket launch in the universe. For these examples, just to be sure of the comprehension of Newton's third law, if you have these photos, which one of them it's not application for Newton's third law? Which one of them? Photo A or B or C or D? Which one? I guess all of you know the answer, which is, the answer is A. In this case, the state or F1 and F2, they may be in equilibrium. Because we have two different objects or two different persons apply on the same object. احنا في الأكشن reaction أو Newton's third law, we have just only two objects or two bodies, just like here. A bullet and the gun, and here your finger with the wall. When you apply with your finger a force on the wall apply on your fingers another force too with the same magnitude but in opposite direction. هتلاقي صباعك بيوجعك. As we have just explained the example of the rocket, the gas or the rocket apply with hot gases comes out and the rocket moves up because of action-reaction forces. But in this case, we have two persons, okay? And if this object is not moving, which means the applying force by the first person is equal to applying force with the second person, which means the two forces cancels each other. And so the box in the middle keeps its state, which means the force in equilibrium state. Which of the following graph represents the relation between the magnitude of the reaction force F2 and the magnitude of the action force F1 when drawn by the same drawing scale? في هنا عملنا a relation between F2, which is the reaction, and F1, which is action. Which graph of them represented the right relation of them? طيب, first احنا متفقين ان ال F1 equal minus F2. F1 equal, which means they have the same magnitude, which means the ratio, it's always between F2 over F1 or F1 over F2, it's always 1. And we are agreed that the negative is just indication for the direction, which means the two forces in the opposite direction. طيب, ده معناه ان two forces equal. تمام, which means it's always F1 over F2, F2 over F1, F2 over F1, it's equal 1. طب لما احنا هنجيب الريشيو F2 over F1 دي عبارة عن ايه بالنسبة لنا؟ represent the slope of the line. دي ال slope of the line. طب ال slope of the but we don't have any numbers on the two axes. انا ما عنديش اي numbers عشان اجيب ريشيو between F2 أو over F1. تمام, ما عنديش number على ال y axis ولا ال f axis. طب احنا عارفين ان السلوب اصلا هو عبارة عن ايه كمان؟ tan of the angle. Which angle? The angle that makes the line with the positive direction of the x-axis. يبقى أنا عشان أجيب ratio between F2 F1 أنا محتاجة أجيب slope of the line و slope of the line. لو أنا ما عنديش أي numbers أو أي data على الأكسس عندي فهجيب مين؟ tan الانجل. وإحنا اتفقنا إن F2 equal F1, which means أنا محتاجة ال right line أو right graph هنا اللي هيكون السلوب بتاعه equal 1. طب which one of them have the slope equal 1؟ اللي هي tan الانجل equal 1. which one؟ اللي هي tan 45. tan 45. So tan 45 هي دي ال right answer عندي لأن دي ال slope of the line equal 1, which means delta y over x over delta x or F2 over Fy equal 1. If the earth affected your body by a force of 600 Newton, your body affected the earth by a gravitational force of a magnitude. So as the earth apply on your object or on your body by a force 600 Newton, your body will apply on the earth another force or as a reaction force which is equal 600 Newton. But in some cases we may have some misunderstanding or confusion. يعني احنا دايما بنقول يعني ممكن يختلط علينا الارض، الارض هي اللي بتجذبنا اصلا، بس احنا ما بنجذبش الارض. فالمفروض even لو احنا هنعمل attraction force or gravitational force applying on the earth, it's going to be less than 600, but it's not true. Each action has equal and opposite reaction. And this is all for today, and let's go and have a summarize on the light board. Newton's third law. Okay, and we have the text of the law, which is each action has opposite and equal reaction, which means if we have a force with a magnitude F1 applied on an object, this object will apply with a force on the first object with another force which is equal in magnitude but in opposite direction. And we said a negative sign, which means this is the direction of apply of the second force. And we call this force action, and F2, this is a reaction. So this is why we call each action has equal and opposite reaction. And we took some notes about the action-reaction forces. We said, the first note, there is no single force in the universe, which means the force is always in pair of forces because they generate together and vanish together. يبقى first note, no single force in the universe. Second, we said the action force and the reaction force, they have the same type, which means يبقى F1 and F2 they have the same type، نفس النوع. يعني ايه؟ يعني لو انا عندي الاكشن فورس جرافيتيشنال فورس، فالرياكشن لازم كمان هتكون جرافيتيشنال. واحده فريكشن فالثانيه كمان هتكون الرياكشن اتس gonna be a friction force. فالاثنين التو فورسز اكشن and reaction from the same type. And as we said here in F1 equal minus F2. And in some times we can find or we can get in some examples that if we have in case of equilibrium, but it's not action and reaction case. If we have a box and you have two person, one person push in this direction and the other one pushes in the opposite direction. In this case, we said the two forces are in equilibrium. في حالة اتزان. equilibrium يعني إيه؟ ليه هنا ما قلتش action reaction؟ لأن أنا عندي هنا the same object and we have two bodies or two persons apply on this object. So the forces cancel each other, and we said if this box is not moving, we will say if this is F1 وعندي هنا F2 إن ال F1 equal ال F2, which keeps the object in static equilibrium. تمام. لكن عشان يكون في عندي اقول ان الفورسز الموجوده عندي اكشن رياكشن لازم يكون في عندي هنا just only two object, just like you have a box here and just only one person push this box with the force. Person apply with the force F1 and the box apply with minus F1. This is all for today. Thank you, and I hope you have spent a good time and useful time. Thank you. I'll see you next time, inshallah. Thank you, my dear student. This is all for today. I hope it's useful and it was interesting for you as it was just for me. Thank you. I'll see you next time, inshallah, on channel Madrasetna 3 under supervision of Ministry of Education. Thank you and goodbye.
أولى ثانوي، فرصة جديدة وحلم جديد وهنعديها بالتأكيد. وهنعديها